Talk about what can we do to find a greatest common factor. We've talked a little about factors of numbers, but we want to think now about the greatest common factor or highest common factor. You may have heard of this as the HCF or the GCF. So we talked about factors already, and we said that factors are anything that we can multiply together to create another number. So things that multiply together to create a product. And the second way we thought about it was factors are numbers that could evenly divide into something. So when we're looking for greatest common factor, we're really comparing two separate numbers and thinking about the biggest factor that they both have. That's what it means to be in common. So the largest factor that's common to both. We have three different ways to find those. We'll practice one of each: factor trees, T-charts, and using down division.
Okay, so we want to find the GCF or HCF of 18 and 30 using factor trees. Okay, and we're going to keep in mind that the GCF of two numbers is the largest factor common to both. So we want to set up our two numbers here, and when you start out here with your factor tree, you can pick any two factors of 18. So it doesn't matter if you and your friend pick different ones as long as they're both factors of 18. So we have 2 times 9 will give us 18, and then 3 times 3 is 9. And Miss Andrews, how do you know when to stop?
Well, if we circle the prime numbers, anytime that we get to the end of a branch with a prime number on it, and that gets circled, then we know that we've sort of hit a dead end there, because the only factors of 2 are 2 and 1, and so we'd be repeating numbers there.
Okay, so if we want to write 18 out with its prime factors, we could say 18 is equal to 2 times 3 times 3. So those are all the prime factors of 18. Now let's look at 30. So again, remember, you can pick any two factors of 30. So I don't know, let's use 6 times 5.
Okay, so 5's prime, but 6 is composite, so we can break that down into 2 times 3. And those are both prime numbers. Oops. So here we have 2 times 3 times 5 gives us 30. So when we're thinking about the largest factor that's common to both, when we look at these, we see that they both used a 2 and they also both used a 3. So 2 gets divided into 18, 3 gets divided into 18, and they both also get divided into 30. So think that those are being multiplied together. If we multiply those, we get 6. 6 is our GCF, our greatest common factor of 18 and 30.
Okay, so our second method for finding a greatest common factor is using a T-chart. So here we want to find the greatest common factor of 18 and 36 by using a T-chart.
So we're going to start with 1. We think, does 1 go into this number? And if so, how many times? So 1 will always go. Does 2 go into this?
Yes, it does.
How many times?
9 times.
And 3?
Yep.
How many times?
6 times.
Does 4?
No.
Does 5?
No.
Does 6?
Yes.
Well, we already have it here written on the other side, so we know that we have all of our factors here. And we do the same thing for 36. 1 goes in how many times?
36.
2?
18.
3?
12.
4?
9 times.
Does 5?
Nope.
Does 6?
Yes, 6 times.
6 goes in 6 times, and we have a repeat, so again, we know that we have all of them. So then we look in both of our T-charts for the largest number that's there, and we have that 18 is the greatest factor of these two values. So here, 18 is our GCF of 18 and 36.
Okay, and we see in this problem that we have a lot of common factors. They have a lot of numbers that are factors of both, but for greatest common factor, you have to just find the largest one, which is 18.
Okay, so our third method using down division tends to be the best way for large values, because sometimes we're not going to want to write out all of our factors of our bigger numbers. So it becomes actually a simpler process if we use division with both of numbers at the same time. So we write the two numbers side by side, and we sort of put an upside down division house, and we think of any number that can be divided into 48 and into 64. And again, this is one of those things, maybe you see one number, your friend might see another number, but whatever it is that you see first that divides into both of these is what we should use. So what pops in your head, Miss Conley?
Well, they're both even, so we know that 2 goes into both of them,
Okay.
so let's try that.
So we put 2 here outside the division, and then we say 2 goes into 48.
24 times.
And 2 goes into 64.
32 times.
Okay. Then we have to look at this next new set of numbers. So it's almost as if now we're ignoring whatever we had there before. We only want to look at the 24 and 32 and think about what numbers go into those.
Okay, so I think 4 goes into both of those.
Okay. 4 goes into 24.
6 times.
And 4 into 32.
8 times.
Okay. Anything into both of those?
Definitely 2. They're both even again.
Okay. And 2 into 6.
3 times.
And 2 into 8.
4 times.
Anything into 3 and 4?
No, just 1.
Okay, so when we hit that spot where the only number that can be divided into both of these is 1, then we know that we have fully factorized them. So we look here on the side, and all of these numbers, the 2, the 4, and the 2, were all numbers that we divided into both of our two values, into the 48 and 64. So we want to think about what would these all be multiplied together, and that creates our greatest common factor. So 2 times 4 gives us 8, times 2 gives us 16. So here 16 is our HCF, or our GCF, greatest common factor or highest common factor. And 16 goes into 48
3
times and into 64
4 times.
4 times.
So keep in mind that these 3 different methods are all finding the same thing. So if you did this same problem using a t-chart or using a factored tree, you should get the same answer. You should get 16 as your GCF.